Remember to not let your phone go to sleep and turn on Do Not Disturb for those disturbing telemarketing calls to shut off the phone while you're recording. I don't know why it does that, but it does. Where were we? We were saying if you want to change your latitude, you go more north or south, because latitude tells you how far north or south you are. So that's where you move. If you want to keep the same latitude, here we go, you move east or west, because then you're not moving north or south. That is, you're not moving away from the equator. Notice the equator is a circle, a line here, but a circle. And so what we've got is a line or a circle of the same latitude. And that would be like this, the same latitude. All these places would be the same latitude. Now we're going to use this in chapter 4 to see why we have seasons, why the sun path is the way it was in chapter 1. We'll finally solve that puzzle, but it's going to take us a bit to get there. We've got to lay this foundation. So we're going to use that, and I'm going to call that a north latitude, NLT. Okay? I may not have that in the book, but north latitude. And so if it turns out, if you go north, or excuse me, you go east across the United States, you hit on the East Coast, DC, Washington, DC. Pretty much, you know, good enough, right? It works. Washington, DC. So north latitude. Now let's talk about measuring latitude. Talk about different latitudes. So that's the whole gig right there. Now, I'll say this. Circles of the same latitude are called parallels because they're parallel to what? What are they parallel to? You've got that in there, right? You can pause this if you need to. Parallel to, that's right. The equator. Okay, parallel to the equator. So notice that that is all the same latitude moving east or west parallel to the equator. Well, how much is that latitude? Well, remember it's kind of an angle. And again, don't worry about that angle. Just know that more angle means more north or more south. In fact, if this is 0, what would the angle be going up, up, up? What's the angle with the equator going to North Pole? So we call that, I'm going to write it this way, LT, it's kind of my way, NP, so the latitude of North Pole, is equal to, we could either say it's 90 degrees north, people say that, you'll see it on maps, or you could also write, same thing, plus 90 degrees, because we tend to draw the globe this way and think of that up and whatever, plus 90 degrees. That's what the latitude, now we're going to use this in the next video in a challenge, so make sure you remember that this is not north or south of the equator, 0. This is the most north of the equator, and then the most south of the equator. What's that angle? Of course, 90 degrees. That's why we did the angles, right? So that is a latitude of South Pole is equal to 90 degrees, which way? South or negative 90 degrees. You'll see it both ways. Fine. So just that idea. Great. So then what would the latitude of San Francisco be? It actually depends on what neighborhood you're in. It can vary by arc minutes and even arc seconds. You see that. You'll see the little symbol, like this 1/ for arc minute and 2 for arc seconds, but we don't need to go too much into it. Let's just say that, and this one is going to be useful. We're going to use it here in a second. That the latitude of SF is equal to 38 degrees. Now, if I don't have a plus or minus, then you're going to say that's got to be north, right? You can put north here if you wanted to, or just a plus sign either way. And that is equal to the latitude, good enough, we're going to go with this, latitude of DC, Washington, DC. Which gives us something interesting. Now, I'm going to cheat a little bit here, a little preview, and that is Earth spins eastward. Earth spins east. I'm looking at that. You need to look at that. That's fine. Earth spins east. If I spin east, things rise in my east, and they set below my horizon in the west. That means that in about 3 hours, people in San Francisco get to visit Washington, D.C. But they can't go to the museums because they've moved too. So Earth spins eastward once a day, or once around a day, as you know. And we'll talk about that. Now, you might have heard that, you might kind of know that, but you're going to really know it when we get through chapter 4. Things that are not obvious. Why? Because we're going about our business. Okay, so latitude equator is 0. It's not north or south of the equator. The most north is 90 degrees, like that. The most south is negative 90 degrees. San Francisco and DC are about 38 degrees, so I make that angle about 38 degrees. I did. I actually used the protractor pretty much to figure that out. Let's see if I got it. Not bad. Maybe more like 42 there, but whatever. Okay, and so San Francisco is going to spin over to DC, and DC is going to, and that means you're going to see different things, right? As you spin, here's San Francisco, they can't see you. As they spin around, now they can see you. Now notice that DC gets to see you first. We see them first. San Francisco's got to wait 3 hours, then you can see it. Whatever DC sees, we're going to see in 3 hours in San Francisco. Interesting. How far north you are will affect what's above your horizon. You go farther south, then you see different things over your horizon. And then throughout the day, so it's a lot. I know it's a lot, so don't get overwhelmed, because it takes a little. You can get it just like an instrument, but it's going to take a little bit of time to master that. But this is the idea. Okay, I think we've almost got latitude done. Latitude's like lateral. If you know football, laterals toss the ball to the side, kind of parallel to the ground in a sense, a lateral, or to the side, lateral or a parallel. And notice this. I want you to notice this, because we're going to use this. Notice that this is less north. So less north, you'd have a smaller angle. And this would be all the same latitude, right? All those places would have the same latitude, and this would be more north. So if I want to draw all the places with the same latitude, I can go down here and I can say, hey, and we're going to do this, a south latitude, that's a south latitude, whatever angle that is. This is going to be less south, and this, of course, is going to be more north, and the most north we can get here. There's kind of a fun things about the Arctic is defined by a certain latitude. I don't know if I should say it. I don't want to overload you. 90 minus, I'm not going to say it. And the Antarctic similarly, and so we map out Earth. But for our purposes, it has to do with what we can see. And we're going to use this. This changed the world. It gave humans power. And when things give humans power, It can be used for good, and it can be used for bad. So, you know, a lot of us think that ultimately it's good wins, we hope. And so we fight for that. All right, that's all. That's latitude. Okay, now what if I go over here? Let me throw San Francisco in there. Right around there, something like that. SF, DC, and everything in between, so we kind of capture the whole US. Of course, there's other people too, other countries, but and that would be a latitude of 38 degrees north, if you want. And what about other places? I mean, what's the difference? So they've got the same latitude, but they're obviously different places. DC is east of San Francisco. San Francisco is west of DC. And we know the whole, I think I'll go throw that in here. That would be south. That would be north. We're going to use this here in a second. How can I talk? I can talk about how far north or south I am. How do I talk about how far east or west I am? Well, I just need to have some place where I call 0. And that's really arbitrary. But it has historical reasons for what we do now. Okay. So the question is, I want to know the amount or the angle east or west from somewhere. And what I use there is, what color should I use? I should use green because it's called Greenwich. No, it's not. Greenwich is how it's said, and it looks like sandwich. Greenwich. Think London. It's just basically like a neighborhood of London, a borough of London. So, and this is 38, and it's something like 51. And we go across the Atlantic, and we go over here. So it's going to be up here. Okay. I'm going to say London, if you want to think of it. You can think, Greenwich. Greenwich is how it's spelled, but Greenwich. Okay. And because of the history of sailing the seas and figuring things out, etc., the Royal Academy, the Naval Fleet, the Royal Academy, there's a astronomical site at Greenwich that has tremendous historical import. When you're traveling, you're going to see with latitude in the next video why it's easy to tell how far north or south you are. It's even kind of doable to tell if you're traveling east or west directly, or north or south, by looking at Polaris. So it's got to be nighttime, right? And there are other ways of doing it. So that's what people, the navigators, it was clever. They had to use a little geometry and try to figure this stuff out. Important, right? It's for you to go across the seas. So, but it turns out it's easy. In the northern hemisphere, it's really easy to find what your latitude is. But finding out how far east or west you are is really tricky. And so there was a competition with a big money prize. There's even a book called Longitude. And anyway, leaving out the history, this line here is all these. Now remember, it's a ball, so I'm not going to draw it straight. I'm going to connect a half of a circle. I'm going to divide Earth. Well, I'm not there on my picture. I've divided Earth. And it goes through here, and so we say the LG of Greenwich, I don't know, whatever you want to say, London, Greenwich, GR, is called 0. And then you can talk about going to eastern longitudes from 0 around halfway halfway around is 180 degrees. I'm not gonna go crazy with that. Or you can go westward around halfway, 180 degrees. Again, we're not gonna do too much with this latitude more so, but I thought it to be complete. So this tells you, notice that, watch this, Washington DC has a longitude here. San Francisco has a longitude here. Who's more west from this line, more west, is San Francisco. Gravity. San Francisco, right? Less west, more west, but they are west of that line. And then you can go east. So San Francisco and DC have the same latitude. It's so easy to say, you gotta check yourself. They have the same latitude, but different longitude. Longitude, whatever you take. Longitude, east-west, latitude, north-south. Whatever memory aid you gotta do, and just look at it and just spend a little time with it. Okay. All these have the same longitude. It's a half circle, same longitude. So go around from this half circle, this one, connecting North Pole through Greenwich or London to South Pole, and to change longitude, then I've got to move east or west, right? That'll change my longitude because that's what it's all about. To keep the same longitude, of course, then I would move north or south. And you can see that from that picture. So I'll just leave it at that. Let you look at it. So that's flipped, right? And those two angles will tell you a particular place on the sphere, not flat, Earth. Not perfect sphere, it's a little squashed on the poles. Get into that detail, and I leave it to you. Have I taken care of business? I think so. I think we're ready. To a quick summary and then go on to the challenge. Oh, thank goodness, it's still running. Alrighty.